Well, hello there! I hope you're having an amazing day, my friend. And also, I hope that you're feeling at least a bit of excitement for today's video. Because today, we will be starting our discussion about basic methods that are available to us in Rust for manipulating characters. That sounds awesome, right? Whoa, not so fast. What are methods? Why, thank you, kind sir, for a very meaningful question. And the explanation is coming right up. So, I don't know if you remember, but we already covered the basic definition of a function in our discussion about the main function. If you do not remember what I'm talking about here, please click the link here and you will be taken to the video where we're going to cover main function and you will see the basic definition for a function. So, a function is a piece of code that we can use over and over again as many times as we like, without the need to actually repeat the same code again and again, because that would just be a mess. Imagine just the scenario where you have to invoke the same identical functionality 10 times. And if you were not using functions, you would have basically to copy and paste the same code 10 times in your project, which just is terrible practice. I hope you agree with this. And also, using function allows us to break our problems into smaller pieces which are much more manageable and easier to handle in our day-to-day lives, which makes our code more readable, easier to maintain, and yeah, it's just benefits basically. So using functions is an amazing thing to do. Excuse me, I don't know if you noticed, but I asked about methods, not functions. Yeah, I get it. It's no problem. I will explain methods right away. So basically, methods are 99% the same and identical thing as functions. So basically, it is a very common thing that people are switching around terms method and a function in their day-to-day usage of these words. But there is a slight difference between those two words, and you're about to find out what that difference is. So functions are basically completely standalone pieces of code. They do not rely on structs or anything like that. Structs? What are structs? Yes! Nice point. I know you do not know what struct is, but struct is a very similar thing to the concept of classes in all other object-oriented programming languages. It can be observed like a class. It's a very similar concept. But if you do not have any prior experience with any of the other object-oriented programming languages, do not worry about it, we will cover structs in great detail, and all of those videos are coming very shortly, so stay tuned for that. You know I've got you covered, my friend. Okay, now back to our main point here. What are methods? So, as I already said, when you define a struct and inside of, or a class in other programming languages, and inside of that struct, you have created some functions. So you have created a function which is defined inside or is basically attached to that struct that you have created. In that case, it's no longer called a function, it's called a method because it relies on the struct that it is created for. So basically, there is a connection between a method and the struct. And when it comes to functions, there is no such connection. They are completely standalone, as I already mentioned. I hope all of this makes some sense to you, and if you have any questions or concerns, I invite you to share them with me in the comment section below this video, and I'll gladly try to explain as much as I can, of course. Well, alrighty then, now that we are familiar with the concept of methods, it's time to actually learn which methods we have at our disposal while working with characters in Rust. Have in mind that in this video I'll be talking about some of the most basic character methods that are really commonly used in your day-to-day life as a coder. This list that I'm going to cover today is much more extensive, and you can find all about it in the official documentation about characters. And I have attached this document in the description of this video so you can easily find it and extend your knowledge. So basically, in this video we're going to cover some basics, and after we have done that, you'll be able to manipulate characters like a true boss. But before we get started with our discussion about methods, I have a question for you. Have you ever seen this character right here? Does it look familiar to you? I think that if you were using computers often and were working with any kind of documents and you were trying to open them, you might have stumbled upon this character. It's a special character that is supposed to represent the scenario when the character is not valid. So, if you remember our discussion from the previous video about characters in general, you know that characters are basically represented by 4 bytes of memory. And inside of those bytes, we basically have a number. And those numbers are being translated into a character by our compiler. And there are ranges of invalid numbers, if you remember from the previous video again. So when you try to convert one of those forbidden character values into the character itself, you will get this exact character right here. Now it's time to cover our first character method. Let's get started from one of the most important character methods out there, and that is from U32. I think the best approach here would be to use our imagination. So imagine the following scenario. You're doing some computation and you're working with numbers, and for some unknown reason your boss reaches out to you and says, hey, I want you to use the final result that we get after these calculations, and I want you to convert it into a character. I want to see which character do we get after all of these computations that we are doing in imaginary universe, let's say. And when you need to do this, from U32 is your go-to method, because it will allow you to convert a number into a character. And of course, I'm aware of the fact that quite a few of you might have already figured out that we are open for quite a few problems if we are using this method, because you can see that it's basically only supporting U32 as a data type of numbers that we are going to be converting, because U32 has 4 bytes of memory, and as we already know, characters are using 4 bytes of memory to be represented, which is why they're equivalent, so to say. And what if our numbers are going to be in other data types? So basically, what if we are working with signed integers, or if we are working with U128 or something else maybe? Well, in those cases, you'll have to be smart and figure out a way how you're going to transform those numbers into U32. And if you're working with data types like U8 or U16, your work is basically cut out for you, because you can always put those numbers into U32 without any trouble whatsoever. So the problem is going to be the scenario that I firstly mentioned. But I just want you to have in mind that this problem might happen. Okay, great, now that we know what U32 does for us, it's time to see it in action. Oh my god, this video is going to last forever if we keep going like this. Time flies when you're having fun, right? I mean, I completely agree with you. If we continue like this and cover both theoretical and practical approaches in this video is going to last for a very long time, more than half an hour for sure, and I do not feel like that's a good time frame for a video, because our attention is going to drop significantly and I don't want that. So I'll create the next video, so it's going to be dedicated only to practical aspect of these methods that we are talking about in theory today. So stay tuned for that. Amazing! Now that we have decided that we are not going to cover the practical aspect of each of these methods, it's basically time for us to jump right to our second method of the day. And this one is going to be isAscII. And as you probably have guessed it already, this method is going to return us true or false based on the fact if the character that we are checking is within ASCII range of characters. And yeah, that's basically all that this method does. It just returns a Boolean value based on the fact if the character is or is not within the range of ASCII characters. So I think as a good preparation for our next video where we are going to dive deeply into practical aspect of these methods, I feel it would be good to take a look at the previous video where we're discussing characters in general, and you can take a look at the last part where I was basically printing all the U8 values into characters. So there you will be able to see all the ASCII values that are basically available to us. So if in the next video you see the value that is also been displayed in that for loop where we were going through all the ASCII characters, you will know that that character basically is ASCII character. And if not, you will basically know that the character you're looking at is not within the ASCII character list. Okay, now that we covered that, it's time to extend our knowledge even further. We are going to cover quite a few, but very simple methods that are being used very often. They are like extremely useful methods that you will be using basically very often as a developer. The first one is going to be isWhitespace. And I think you already know what this method is going to do for us. Basically, we will receive true if the value in our character is basically a white space. And if it is not, we will get a false as a result. So just have in mind, you will be using this method a lot when you want to check if your, for example, string contains some extra white spaces or something like that. And you convert it to character array, and then you go through each character and you check if it is a white space, and if it is, maybe you want to trim it, or you just want to make sure that you have a single white space, not many, or whatever your current problem is going to be at that moment. But I just want you to have it in mind because it's a really useful method, and a very simple one as well. Also, I mentioned we have isUppercase and isLowercase methods. So if we are using isUppercase method, we are going to receive true if the letter that we are checking is uppercase, and it's going to return false if it's lowercase. And in the other scenario, when working with isLowercase, we are going to receive true if the letter is in lowercase and receive false if it is in uppercase. It's as simple as that. And now we have two more methods. Those are going to allow us to check if our character contains an alphabetic value, so like a letter, or if it contains a digit. And for those scenarios, we are using isAlphabetic or isDigit methods. So everything works very simply. You just invoke these methods and you will receive, for example, for isAlphabetic, you will receive true for each value that is a letter. And for isDigit method, you will receive true every time that you are working with a digit. But have in mind, there is a slight plot twist here, because for isDigit method, we need to send a parameter. We need to send a number that's going to specify which number system do we want our compiler to use while checking if the value within our character is a digit. And what might be the actual point to do that? It's fairly simple, you'll see. Do you remember our discussion where we mentioned that we are able to be using different number systems, and one of those systems was hexadecimal system. And inside of it, we had values that are in range from 0 to 9, and those are your regular numbers, but we also had letters A, B, C, D, E, and F. And those values were representing basically numbers from 10 to 15. And if you are using hexadecimal number system, so the radix of your number system is 16, and you test letter A with isDigit method, you will get true, even though you're basically looking at a letter. But that doesn't matter because that letter has a significant value and it represents a number inside of that number system. Also, if you take a number 3, for example, and specify number 2 as a radix for our number system, so basically we told our compiler that we want to be working with binary number system, it's going to return us false, because in the binary number system, number 3 does not exist, because we only have values 0 and 1, nothing more than that. So number 3 is not a valid digit, which is why isDigit method in a scenario like that would return us a false. Just have that in mind. I hope that everything is much more understandable and clear right now. And now, ladies and gentlemen, it's time to cover the last category of methods that we have at our disposal for working with characters. I'm talking about transformation methods. So we will be basically covering 2 lower, 2 upper and 2-digit methods as our dessert of the day. As the names indicate, you probably know what each of these methods does for us. So basically, 2lower method is going to return us a lowercase variant of any character that we send to it. Of course, I'm talking only about letters. If you send an emoji to it, it will just return that same emoji. It will not return a lowercase option of that same emoji. I'm pretty sure that no lowercase emojis exist today, right? Or maybe they do exist. Let me check. Lowercase smiley faces. And search. Nope, no lowercase smiley faces available. So I was right. There is also 2 uppercase method, which does exactly the same stuff as 2 lowercase, except it does it in the opposite direction. So if you send it a lowercase letter, you will get back an uppercase letter. So very simple story here. And finally, we have our third method here, which is 2-digit. And this method is going to return us a numeric version of a character that we are using this method on. So if, for example, you are using a character of number 8 with this method, you will receive number value of 8. And of course, for this method, we will again have to specify what is going to be our desired number system that we want to be using. So our compiler would understand us really well and know exactly what we want it to do. So basically, now you know how to do all of this stuff. Whoa, that was a lot of stuff, I have to say. We managed to cover a whole bunch of stuff in theory, but nothing in practice. So we basically cannot use any of these methods in reality still. But do not worry about it, because you already know that our next video is going to be dedicated just to that. And I also am aware that we did not visit our Visual Studio Code today, so it's probably going to miss us very much. We have to pay some attention to it and spend some quality time with it. I hope that you agree with me on that one. So in our next video, we will definitely have to do that. So, if you found this video useful, even though it was a very theoretical approach and we spend a lot of time talking about just theoretical stuff, besides all that, I still hope that you learned quite a few new things that are going to be very useful to you in your day-to-day life as a future Rust developer. So, if that is the case, I would like to kindly ask you to subscribe to this channel and leave a like on this video, because that is going to help both me and the channel to grow and also spread the word about Rust programming language to as many people as possible. And for your support, I'm really thankful. Yeah, I don't know if you noticed, I just purchased a new mic, so I hope the quality of the sound is going to be a bit better than before. So please do feel free to share your opinions in the comment section below this video if you like this mic more than the previous one. So yeah, I hope it's going to be better. So as I already mentioned quite a few times, in our next video we will be talking about practical approach of all of the methods that we covered in this video. So if that sounds like your cup of tea, stay tuned and join me on that video. And there is only one thing left, and that is for me to wish you an amazing day. And until the next video, goodbye!